We are 3D ANC, and this is going to be a demo of our project. So just to start with our physical setup here, we are using this guitar amp to input a loud sine wave into the box. And then our noise cancellation system consists of these 4 speaker microphone pairs that are going to use our special adaptive filtering algorithm to cancel out the sine wave and create a region of quietness or less loud in the center between all of the speakers. And we're going to demonstrate that by turning on the sine wave and running our system and trying to show the audio levels and also utilizing this decibel meter to kind of show the sound. So for some more of our hardware, we have 2 preamps to enable functionality from our microphones and connect them to our analog devices DSP board, which is an ADAU 1452 evaluation board for one of their specific DSP chips. And the way that we programmed it is using this Sigma Studio Plus software, which is proprietary for analog devices and kind of built for their chip specifically. And just for a quick walkthrough, we are taking in the inputs, which are our speakers, applying some small transformations and sampling for turning it into something the chip can actually use, applying our adaptive filtering to it, and then adding a low pass filter and upsampling so that we can output it to the speakers. And you can see that they're kind of all interconnected together so that we can make our whole system. So to start, we are going to turn on our filtering. You can see that we needed to do some training to generate our secondary path coefficients, which is kind of like just calibrating our setup for how far apart all the speakers and microphones are, kind of localizing in a sense. And then we can upload those coefficients and start on training our primary path, which is kind of just us running it. So Hiroki, you got this. So we're compiling and downloading right now, and it should be running. Yep. And so now we can start our 200 hertz sine wave, kind of just as an example of input noise. And you can hear that's coming straight from this amp. And so using our decibel meter, we can kind of show in numbers what the volume is at different levels. So you can see here by the amp, it's about 92 decibels, which is very loud. And then as we get closer to our system inside, you can see it's already dropped significantly to roughly 70-71 decibels. As we move kind of up in space, we can see it's climbing 85, 87, 88. Yeah, just getting louder basically when we get outside of this spatial zone of quietness. So when we move up, when we move to the side, it gets louder. And here in our zone, you can see all our speakers are kind of pointing to this central convergence point, and that's where our sound is really the quietest, and we're getting that 70 decibel reading. As soon as we go outside, back to around 84, 85. And so I'm gonna try to point the microphone of the camera in different places just to see if you guys can hear it in the video. So this is it, very close to the amp, the sine wave, the external noise. And here we are getting closer to the inside of that spatial quietness area. And then here we're gonna move up and outside of that area. I should be getting louder now. And even if we're down here, if we move spatially a little bit to like the left or the right, we can see that it should be getting louder outside of that zone. Thank you so much.